is network layer. Okay. Fourth is transport layer. Okay. I'm sorry for the spelling. Fifth is session layer. Okay. Sixth is presentation layer. Presentation. Okay. Presentation layer. And last one is application layer. That's fine. So,
Yes, sir.
so for see that there is a one PC and there is a one PC. If packet is if this PC say hi to this guy, say hi to this PC. This is the PC1, PC2. If this PC say hi to this guy, it has to be go from this there to there. But okay, okay. So let me explain from other slides. Actually, it is not a part of. I'm sorry for that, but it is not a part of actually this course. But I want everyone should be understand. So see that.
Thanks.
Okay. So what happened? This is my PC1. Okay. This is PC1. This is PC2. So if this PC initiate or open a one connection from browser. Okay. Browser. What is browser? We all know that Google Chrome, Edge,
Yes, sir.
right?
Yes.
So if it's open a PC or open a browser and just try to initiate one connection to accessing PC2. So what happened? So it is working on application layer that time. Okay. From the application layer, it will then packet move to presentation layer. What presentation layer is actually does? Let me explain the application layer. Application layer is the layer where all the application are working. So browser is if you're opening a browser, it's all stuffs are working application layer. So like if you open a browser, you will type HTTPS, right? Kind of stuff, or facebook.com, HTTPS, facebook.com. What is HTTPS? HTTPS is working on 443, right? Hypertext Transfer Protocol secured. Or like AT or AT is what HTTP or telnet. If you want to do telnet, these are the some port or protocol is all working on application layer. That's fine. So if this guy open a browser, say hi to this PC. So first it is working. First packet would be in application layer. Then it will come to the presentation layer. What presentation layer is doing? Presentation layer is actually giving you a just like a form of your data, like PDF form, Excel form, any other form, or whatever the form you want. So that's a form actually made by the presentation layer where your data would be you are able to view or type. Then once you initiate a connection, it will open a session. So session is what is actually making a connection. Okay. It is if you try to make a connection, it is actually all connection detail would be you will find in the session. Then it will come a transport layer. Transport layer is a very important layer actually. What transport layer actually does, like what are the services you are using? So like if you are using a TCP, you are using a UDP, okay, even ICMP, those are a protocol is actually working on or in the transport layer. What is TCP? TCP is a transport control protocol. UDP is user datagram protocol. ICMP. So these are actually, what is TCP? These HTTPS, these AT, telnet, those are the application of TCP protocol, right? So those in the transport layer, like suppose this PC, okay, we all know that TCP three-way handshake, right? See, if this PC want to initiate a connection with this guy, so this guy, if want to connect, initiate a connection, if it's a TCP protocol, always remember this TCP protocol would be it's a services kind of stuff. It's a port number, right? So this protocol is actually giving you the acknowledgement. Always you will get an acknowledgement. If this guy say hi, he will also reply on your mail hi. Okay, but UDP is not any. It means it doesn't give you the acknowledgement. What is acknowledgement? Means reply. Okay, like if this guy say hi, he will not reply. Even this guy don't know my packet has reached or not. But in TCP you will get a full-fledged information that my packet, whatever I'm trying to transferring or sending a packet, this has been reached or not. I will get a full information. Okay, so these are the TCP features. Okay, by the TCP flags. If you guys are aware of TCP flags and those, so those are actually happening on transport layer, and then it is network layer. What is network layer? Network layer where you want to reach. So address. So it is working on IP addressing. Okay, so where you want to go, I want to go this PC2. Okay. So this, what is the IP address of this PC2? What is it? IP address is what? Is a location. Like if you want to go somewhere, if you want to go somewhere, okay, this PC1 has a some address 10.0.0.1. Okay, this PC2 has some address 10.0.0.2. This address is actually its destination address. What is the address means? Like if this is you want to go to Goa, okay, you want to go to Goa, so you will sit on such kind of train or flights which is reaching to the Goa, right? So likewise the same, Goa is your destination to go, right? Like you want to go Goa, so Goa is your destination. Likewise, if this PC want to go, this is the IP address of this PC where this guy want to reach. Okay, so now come here. So network layer is actually looking for, okay, what is my source IP? Source IP would be the IP address of PC1. What is my destination IP? Destination IP is the IP address of PC2. Okay, so it will then what it does, it will then paste the destination IP address on the packet. Okay, and then packet will move to the layer 2. Layer 2 is what? Data link layer. Data link layer, what it does is actually look for a MAC address. Okay, what is MAC address? MAC address is the physical address of your PC, right? So it will get the details of your PC MAC address, and also it will frame your packet. This is the packet, whatever you try to send, you will frame your packet, and then it will come to the physical layer. What is physical layer? Physical layer, it means it's convert or is change your packet into electric form. It means bits and byte. Okay, electric form, like bits and byte 1 and 0, because computer understand the bits and byte information.
Only binary language.
Yes, binary language. So those into the electric form, it reached to the just try to open a new page. So what we have learned till now, that this is application layer, transport, session. No, it's a not transport, presentation, session, transport, network, data, and physical layer. See that this is the PC1 for PC1. This is for PC2. So then this is the physical layer. Here your packet is coming and going to the PC2. So there it will reach to the physical layer. Okay, because it was in an electric form. Okay, binary. It will, this physical layer will convert, will change, and then move to the frames for the MAC address. What is, it's a data link layer. It will now then move it to the frames. Okay, and then it again check for the, here it will check for the network. This is network layer. So in network layer it will check for destination, source and destination IP address details. Okay, so you will get the IP address details here, and then in transport layer your packet will be checked by the transport layer. It will check that which protocol you are using. You're using TCP, UDP, or some other protocol. So you will check that you are using TCP, whatever the protocol you are using. In transport layer it is going to be checked TCP. It's also going to be segregate your packet. Most of the things are there, which is I'm not going to explain. It will check your protocol, and then it will make a one connection with your PC2, and then present into the presentation form, and then it will move to your browser, and your say hi message will appear in this PC. So this is the actually whole process your traffic would move. So this is the OSI stuff. Hope you guys understand. If anyone have doubt,
yes, understand.
Thank you. Okay, sorry for that. Okay, so guys, what firewall was doing. So if any unauthorized access, what we learn here, that if any user, if it is not authorized and try to access your network, so firewall have some set of rules. Firewall will check that that traffic and check that whether in the firewall there is a rule is created or not. What kind of rule is created? In the firewall, rule is created like that, like a source IP. For the mentioned source IP, whatever the source IP of this PC, this is a source, right? How you will define a source IP? See, there is a two things. One is initiator and one is responder, like PC1, PC2. If anyone want to initiate a traffic, like say hi, okay? If anyone initiate a traffic, those kind of traffic would come like initiator. That one actually come initiator. Okay, what is initiator? Initiator is that who want to initiate the traffic. That is the initiator. Who is responder? Who is replying to your message. That is called responder. If I say hi, you guys will respond to me, right? Hi. So that is called I am initiator and you are responder. Okay. So due to this, what we will able to understand, whoever the initiator it is, source IP would be from the initiator only, and responder is become destination all the times. Okay. So what firewall will check here? Firewall will check that if there is a one guy who want to access this. So what is the source here? Source would be source IP is the IP address of this PC. Okay. So source IP is the IP address of this PC. Whatever. Let's suppose the IP address of hacker is 11111. Okay. He want to access this PC. This PC IP is 10.0.0.1. Okay. So what is your destination IP? Your destination IP is 10.0.0.1. Okay. On what port or on what protocol he want to access this? Let's suppose he want to access 443. What is 443, guys? It is the TCP protocol HTTPS. Okay. Suppose he want to access. Yeah. So he want to access port number 443. 443. Sorry. So firewall will check that whether in their policies for the source IP 111, destination 10.0.0.0.1 and port number 443, is there is any kind of policy created in the firewall? If there is, definitely it's a hacker, it's not a legitimate user, it's unauthorized. Firewall will see that no, there is a no policy created. So firewall will, what it will do, it will block the traffic. So if it is, so this traffic has been blocked here. It is not able to get the access of my server. Okay. So that's how firewall actually preventing to unauthorized access of your network. So what is the definition of firewall here? That we're going to learn now. So what is
Are we going to discuss any kind of policies also here by chance?
Sorry?
How to write the policies?
How to write
policies?
See, those we can those we can learn when we can move to the lab.
Yeah.
This is the first class, so it's all are the basic. Okay, all are the basic from the what is firewall, what are the types of firewalls. Those were I'm going to explain today. Okay, and could be tomorrow I'm going to explain the architecture design of Palo Alto Firewall, and then we can move for the initial lab of Palo Alto Firewall. Fine.
Yeah, by chance, like can we build any kind of firewall by our own in the lab session at least?
In the lab, yes. See, okay. Once the lab session would be there, right? So then we can, I will show the lab. We have a lab actually. Let me open the lab. See, this is a lab. Definitely all guys would have this lab. So it was a basic I have created. You can create your own. So once the lab would come, I will explain how actually this is the Palo Alto Firewall. These are the PCs I have taken and how the traffic would go. All we can able to see when the lab would come. Okay.
Yeah.
Okay. So actually, there is a many guys who don't know what is firewall. Actually, so those I have to explain everything. Okay, guys. So, so what is firewall? We come to know that firewall is a software or hardware-based network security device which helps organization to protect from unauthorized access. That's clear, guys. Okay.
Yes, sir.
Now we know that what is firewall. Okay. Now I'm going to explain what is types of firewall. Okay. So in the types of firewall, how many types of firewall? There are multiple types of firewall. Okay. So like I'm going to explain right now, this is the packet filter firewall. Packet filter firewall is also used to know as stateless firewall. Okay. So it's an old and traditional firewall. So what it does actually, like this is my firewall and this is my LAN. Okay. In the LAN, suppose there is a one PC and suppose this is one PC outside the network. Okay. So if any traffic like this guy want to access this guy. Okay. Okay. So as I explained, there is a one initiator, there is a one responder. So this guy the IP of this PC is suppose 1.1.1, and the IP address of this PC is like PC1, PC2. This PC is 10.0.0.1. Okay, so if this PC2 want to access PC1, so what kind of rules we can create? I want to allow the traffic. Okay, so what kind of rule we can create on packet filter firewall? Okay, so see, so there is a rule we can create. What is the source IP? We can define the source IP. Source IP is 1.1.1. Okay, see that. What is the destination IP? Destination IP is 10.0.0.1. And on what services? Why he want to access? So he want to access on which services, like 443, 80, whatever the services. Okay, we have a multiple numbers of services, because if you want to access any PC, you want to access on services, right? You can't simply access like that. So he want to access on destination port number is suppose 443. So we can create a rule in the firewall like this source IP 111, destination IP 10.0.0.1 to port number 443. It should be action would be allow. Okay, action would be allow. So if you allow like this, then only we can create a policy in the firewall like this, then only it will allow the traffic. But it's a packet filter firewall, which also called stateless. Stateless. What is stateless? I'm going to explain. So see, so if I will allow the policy like this, it will only allow one side, like one side. So if this PC will reply, this is the initiator, this is responder. I said if this is initiated traffic, he will get a reply, right? Definitely he will get a reply. What is reply? I'm going to tell. I'm going to explain again. Like this PC want to access facebook.com. Okay, facebook.com. So and this is a server of facebook.com. So once if you type in your browser facebook.com, so there is a one dashboard of Facebook cam, right, on the Facebook application. Those actually Facebook is replying to your PC. That's why you are able to see the dashboard of the Facebook, right? So that is actually replying, okay, to you. So likewise, if he said if he want to access PC1, so this PC will definitely will reply. So replying back actually for when the PC1 will reply back to PC2, those information we have to also allowed in the firewall. Okay, so actually my firewall is we have to allow a two connection. We have to allow a two policy for open one connection from PC2 to PC1. Okay, let me explain again. So this is my firewall. This is PC2. This is PC1. The IP of PC1 is 10.0.1. This IP of PC2 is 1.1.1. So if this PC want to access PC1, we have allowed first policy source IP is 1.1.1, destination IP 10.0.0.1 and port number 443. So with this policy, action is allowed. This is I have allowing firewall. So it will only allow one side of traffic, one side. But the reply once this PC will send a reply back, we have to be allowed now. If when the packet is returning, here the source is changed. Here the source is this PC is become source. So here the source IP is 10.0.1, destination IP is 1.1.1, and port number is 443. And action allowed. So here we have to again create a one policy to allow for return traffic. Remember, so that's why for creating a one connection, we have to be created two policy into the packet filter firewall. So that was actually a old traditional firewall where, so for consuming, likewise, if we have to be create 1,000 rules, if we have to be allow 1,000 connection, for creating 1,000 connection, we have to be created 2,000 policies. So it will actually taking a long computing time, or it is actually creating a latency, and it is actually breaking down the throughput of the firewall. So that's why some kind of latency into the network. So then next came stateful firewall. So once I explain the stateful firewall, you guys able to understand what is stateless. Okay. So in the stateful, what is actually in the stateful, as I explained on the packet filter firewall, for creating a 1000 policy, we have to be creator for creating a 1000 connection, we have to be create a 2000 policy in the firewalls. Okay. So, but in the stateful, it is not. In the stateful, if you want to create a one connection, you have to allow the one policy only. Okay. In one policy, it can create a for one connect for any each connection, it can create a, we need to create a only one policy only. So like this is my firewall. Okay, here the this PC, the IP is same 10.10.1.1.1, and there is my PC is IP is 10.0.0.1. Okay, so if I want to allow from PC2 to PC1, I will only need to create a one policy. Like source IP is here 1.1.1, destination IP is 10.0.0.1, and port number is 443. That is enough. Okay, why? Because why it is enough? Why we no need to open or create a policy for the return traffic? Why? Because this stateful firewall is actually maintaining a state table. It is maintaining a state table. What is state table? State table is also called a connection table. So what it is, connection table, it is this firewall, whenever if any traffic would come, it has created one connection table, and in this connection table, it's like a it is storing a data. Like it is storing the data for, okay, what is the source IP? This source IP. What is the destination IP? 10.0.0.1, port number 443. This guy actually want to access, and action is if it is allowed, you want to access to PC1. Okay, so when the return traffic would coming, it will check the state table lookup. It will do the state table lookup and check that, okay, this is the existing traffic is coming. It means it is it is not a new connection. It is the existing traffic which is already went from the firewall. It is return traffic. So if it is a return traffic, and that all the information he will find into the state table, so he will not going to do the policy lookup check. He will simply allow the traffic. So that's actually how the stateful firewall work here. Okay. Anyone have any doubt for the stateful firewall? Right.
Hello.
No, sir.
Yeah.
No, sir. Not as
Yeah,
of
actually,
now.
Yeah. Please go ahead.
yeah, Praveen this side.
Yeah, Praveen.
Yeah, actually in the state table, what information it is stored?
Okay.
On,
So yeah. I will just explain. I'm going to explain again. So in the state table, as I said, after the packet filter firewall, they have created a new generation firewall in the 90s only. So that firewall called stateful firewall. So what firewall it is doing? So whenever if any new connection, see why you require a policy. This is PC1, PC2. IP is 10.0.0.1. This IP is 1.1.1. Simple. Okay. So if this traffic, this PC want to access this, okay, he want to go by the firewall. So firewall, as I said, it maintain the state table. So in this state table, so if just think about if this PC want to access PC1, so the traffic would come to the firewall. Firewall will check that whether this IP is allowed for this IP or not for the port number 443. Suppose he want to access on port 443. So that information he will in state table, he will have the information of source IP detail. Okay, like here the source IP is 1.1.1. Then he will also store the destination IP detail. Okay, 10.0.0.1 and which protocol he is using. Also, actually, he's also storing the source port detail also. Okay, source port detail. What is source port detail? Let me explain the source port. Okay, what is port? Actually, there are around from from 1 to 65,535. That many of ports are there. Okay, so what is a port? So see, out of this 1 to 65,535, 1 to 1023, that many ports are called well-known port. What is well-known port? Well-known port, it means those ports are already defined. How we can say that? Like for the port 80, like port number 80, it is already defined. Like it is HTTP. 443, it is already defined. It is HTTPS. Okay, and then 21 telnet, like 23, sorry, 21 is for
21
FTP.
FTP.
Yeah, 23 is telnet, 22 SSH. Okay,
I have
49.
one small question.
Yeah, please.
Yeah, so we can block all the services only using the port numbers. So we need to keep removing all the port numbers, right?
Yes.
Okay.
So in the firewall, like he's asking that can we block? So like this, I'm allowing like this source IP. Suppose this source IP PC2.1.1. If going to the PC2, he want to access on 80, but I want to block it. I don't want this PC2 get access of this PC 10.0.0.1 on port 80. I don't want to get access. How we will create a rule? We will create a rule for source IP 1.1.1, destination IP would be 10.0.0.1, and then destination port number is what? 80. Action, I want to deny or block. What is it? Allow or deny. So I don't want to allow, I want to deny the traffic. It means whenever if this PC want to access on port 80, firewall will drop the packet of this policy. Okay, so here someone had asked what the firewall will store into the connection table. The firewall, in this firewall, if any PC want to access, so in the connection table, firewall store the information of source IP detail, destination IP detail, okay, then also source port number detail, and then also destination port detail, and then it will open whatever the connection it open, right? So that session ID also would be stored. Only that many information it will stored, and then it will allow the packet. So when the same packet will coming back, firewall will check that okay, it's not a new connection, it's an existing connection, and it will allow it back. Okay, so I'm going to explain the same thing with our local environment example. Like see, like we have in our society, okay, this is our apartment, this is our society, and there is a one watchman. Okay, there is a one watchman is there. Okay, so if there is if any one person, he want to come from the outside, like this is a watchman, here is a one watchman is there. If any person want to come from the outside, what firewall will check that? Okay, what this watchman will check that? Okay, he will ask that what is your name. So he will check his name. Okay, where you want to go? He want to go to meet some guy in this flat. So he will note his name. He will note his destination, where he want to go, to whom he want to meet. Okay, or what is the purpose to meet. All information he will note into his diary or some his registered, and then he will allowed it. Okay, allowed it, and then when the same guy would coming back, this watchman will check that okay, okay, this is your name, this is your where you want to go. Okay, you want to go there. Okay, it means you are the same guy which you have entered 2 hours back, and he want to go back. So he's already aware that this guy is a known for him, right? Because he's already entered, all information is already mentioned in his registered. So then when this guy will go back, he will simply allow him, okay, go back. So that's why same, when the packet is already initiated and firewall is allowed it, for the return traffic, he's not going to check for the new rules, he will simply allow it. Like in the stateless or packet filter firewall, even for the return traffic, we have to create a rule or policy. But here, if it's when it is return traffic is coming back, he will check that in the state table, for the same source and destination and port number information is already there, and it's the existing traffic, it will allow it. So actually what happened, why stateful is advanced than stateless? Because it is not taking much throughput. Okay, it is not there is not much latency. It is not wasting time for computing, because for only one connection it required one policy. But for the packet filter firewall, for one connection it requires two policy. So that is, it is very much advanced, and even still we are using the same technology in our current firewall. Any doubt now?
Manpreet, while the responder is sending back the packet, that source and the destination will be changed, right?
Exactly.
So how does it work in the stateful table? Because in stateful table, the source and the destination would be 1111 and 10.0.0.1. So while
Exactly.
returning,
Very good question. So as I explained, firewall will have a information of source IP, okay, and then information of source port, okay, source port. What is source port? We know that it could be a random port. As I explained, 121024 is a well-known port, and after that, later 1025265535, those are called random port. Okay, random port. So when you open any new connection in your laptop, it will open it will take any random port. Okay, and then it has the information of destination IP. It has the information of destination port. Okay, and it has also have a information of, as I said, connection information, or create a one connection, so it will have a session ID. So that session ID is actually the same ID which is helping, okay, this is a return traffic. That session ID actually helping to identify, okay, it's a return traffic. Okay, so it will check that, okay, when he was checking into the connection table, it will check that, okay, it is the same session ID which is already been established. So that's why firewall will come to know that, okay, it's a existing connection, it's not a new connection. So then firewall will not going to do the all policy lookup. He will simply allow it. Okay, got my answer?
yeah, got it. So the session ID, does it have any age?
No.
How long the session?
No. It is not timeout. It is all, because see, a timeout depend on the protocol. Okay, what protocol you are using. If you're using a TCP has a 1 hour of timeout. If you're using UDP, it has around 5 minutes, or I don't know, of a timeout. So it all depend on the protocol, which protocol you are using. If you're using a TCP, ICMP, okay, so that's all depend on the timeout. Okay.
Okay, yeah, got it.
Okay.
Thanks.
Okay, session ID is just for information. It's like some kind of information. Okay, like some kind of alphanumeric number. So that's how actually it will able to identify. So here, I also want to know the difference. See, in your interview, if anyone want to give,
question. Hello.
please. Yeah, please.
Suppose I have more than one sources. Suppose in my house I have 3 laptops or 3 PCs. Okay, and I'm using the firewall. Just for example. Okay, and the destination is same.
Okay.
Okay. Suppose from source 1 I have requested some traffic. That will be like, it will create some session ID, right?
Okay.
And I'll get back the revert and my session is closed. So what will happen after that? In the firewall, that session ID will be like, it will be removed, or like it will saved for some time. Because in second request, suppose I'm requesting from other source, then what will happen? The same session ID
no. There is no same session ID. Session ID is very much unique, and when you tear down the connection, the session ID and all the MAC address, state table information would be removed from the state table. Okay, it is rephrased. Okay, so I want to also give one example for that. Like, this is your PC. Okay, this is your PC. This is facebook.com. Remember. So if you understand this, you will understand your answer. So if from one web browser, okay, same source IP, okay, your source IP is 10.0.0.1 and Facebook's IP is 111. You want to access on 443, like example, whatever I'm giving. Okay, this is your destination. So see what happened if you open a one session for the facebook.com. Okay, there is a one firewall. What it does for one session, okay, firewall will create a one state table for that. All source IP information, source port information. Remember, source port. So my source IP is same, my destination IP is same, my destination port is same, right?
Right.
All same, but your source port number, it could be some random, like 2222. I'm taking an example. Okay, and there would be a one kind of session ID also created, whatever the session ID. Okay, it's a unique. So again, from the other browser or from the other session, same time, you again open a facebook.com. Again, you have open a multiple facebook.com. So what would happen? Your source IP, destination port number is same, but your source port is all the time changing because it's a random. right? So whenever you open a new session, your new random session port number, source port number would be changed, created. For other connection, your new source port would be different, and your session ID for the each new connection would be unique. All each time it is different. When you close one connection, for information of the for information of all this, it will be tear down, removed. For this also it will be removed. Once you close, it will be removed. Okay. Likewise, if you open even 1000 connection, for that 1000 time your PC, your firewall would open maintain a state table like this. So always remember, it's a very unique questions, very important, not important, but very intelligent questions. Always remember, your source IP is same all the time, your destination IP is same, your destination port number is same. So how come your firewall is distinguishing? Even in the interview it will call, it can ask. So your source port, all the for all new connection, that is new source port is created. Okay, and unique session ID is created. So this thing actually distinguishing your connection. Got my answer?
Okay, got it.
Okay. Anyone have
So
doubt?
in any
Please?
case, source port will
Yeah,
not be
Manjit, sir.
repeated, right?
Huh?
In any case, for a single source, that source port will not be repeated.
No, yeah, it is not repeated. That is no, never.
Okay.
If you, I don't know, I can able to go to CMD. Okay. And net state -a. I think this is a command. See that whatever I'm using all the time, like 49628, 49685, 49686. So these are the established connection. Okay. So if I open google.com,
hello.
Yeah.
Actually, in this case, we are using only a single PC. So same port number. It won't use same port number for all the 3 different connections.
I understood. I understood your question.
Yeah.
Just give me one moment. I just want to answer this. That is very important. So see that all the time, the port number, this is the port, this is the IP. See that this is the IP and this is the port number. Okay, 49685, 4968664. This is all the time unique. Even the IP is same. Okay, source IP is same, but all the time this is the port number is different. This is a unique port number all the time is coming. Got my point?
Okay, thanks.
Okay. So someone is asking that if the PC is different. Okay, nice question. I understood your question. Let me explain.
Yeah, Manjit, sir.
Please.
Sir, does the Stateful hold any MAC address or not?
MAC address information, yeah, it can also hold the MAC address information. Has 2 wings.
So based on the session, the MAC address will also be play a vital role, I think.
Sorry.
Based on the session,
for MAC address information, it can store the MAC address information. Okay, but firewall working on the network layer. Okay.
Yeah,
so,
sir.
Yeah, so firewall actually working on the network layer. For that network, all the network information would be very much important for that. But it can have a MAC address detail, definitely. Okay, but for the MAC address, what would happen? There is a one, as you ask for the MAC address, one time what would happen? This was my firewall. Okay, and this is my PC. Whenever someone initiate the traffic, what happened? Firewall is keep sticking the MAC address, same MAC address. Okay, this is one masquerading attack. I will let you know later on. So firewall have the information of MAC address, but actually see that. As I explained, the source IP, destination IP, source port, destination port, but MAC address is also same for the source IP, right? Okay,
right,
same. It is same. It is not going to change. So what happened? What is the uniqueness for that? Uniqueness is your source port number and your session ID. So that is actually a uniqueness, which is actually distinguishing between the each connection. Okay. So
yeah,
one guy has asking that if there is a 2 PC, and he want to initiate a connection for, this is facebook.com, suppose PC3, PC2, PC1. So see that if there is a 2 PC, so definitely the physical, IP address, I'm not saying physical, but the IP address is kind of a physical IP address. Physical IP. Actually, MAC address is the physical address, but for the layer 3, what is the physical IP? Physical address, MAC IP address. So if there is a 2 PC or multiple PC, he want to access facebook.com. So IP would be different, right? So IP, definitely your IP would be different. So if IP would be different, so firewall easily identify that this is a different IP and it will open a connection for each different PC. Anyone have any doubt? So guys, this is very much important. Now we came to know that what is stateful and what is the difference between stateful and stateless firewall. This is the first question you are going to be asked in your interview if anyone preparing for the interview. Okay, so stateless is nothing, it's a packet filter firewall, which is not. So stateless is the same packet filter firewall because it is not maintaining the state connection. So what is stateful firewall? Stateful firewall is maintaining the state table or connection table. Okay, so it is maintaining the state table, but stateless is not maintaining the state table. And for creating a one policy, we can require the for creating for one connection, you can require the one policy only, but for one each connection, they are required 2 policies. Fine, this is a major difference. And there is a one stateful firewall. It's a very low latency. Okay, low latency means there is a no network choking. The throughput is very high. Why high? Because why the throughput of the stateful firewall is very high? Because there is a less number of policy. Why? Because if we have to be create a 1000 policy, 1000 connection, for 1000 connection we require a 1000 policy only. But in stateless, for 1000 connection it required 2000 policies. So that's why it will take long time for computing. Okay, so that's why stateless has a high latency and low throughput, and stateful has a low latency and high throughput. So that's actually major difference. Okay, that's fine. Now I'm moving to the next. Stateful is complete. What is application level of gateway firewall? So application, it's an application firewall. It's also called a proxy firewall. So application firewall, what actually it does, it only check for a web browser, like web-based traffic. Okay, what is web-based traffic? Web-based traffic is like facebook.com, youtube.com, any type of traffic which you are accessing from your web browser. In this PC, for accessing from web browser, all web browser traffic is called web-based traffic. So any web-based traffic, it's all directly, it is filtered by the application level of firewall. So it is actually working on application level, as I explained the OSI reference model. So what happens if you open a browser and if you initiate any traffic, so those would be come into the application level, application layer. So application layer firewalls, what it does, like if you want to, like if we have a user in the LAN, there are lots of user, it is connected to the firewall. Okay, it is application firewall. Okay, application firewall. Okay, and this is my internet. Okay, so like suppose there are some user. Okay, some user, I want this user to access the facebook.com, suppose. Okay, facebook.com, but I don't want this user to access the facebook.com. So and even I want this user to access the youtube.com. So likewise, we can create a application layer filtering into this firewall. So most of the times, like if I want to allow naukri.com for this guy, okay, but I don't want to allow naukri.com to this guy. So those kind of blocking and filtering we can do at the application level gateway firewall. Okay, so in also application level gateway firewall, we can also block all social media. Likewise, we can block all social media. Yeah, it's also we can do the content based filtering. So those kind of filtering, like we want, we can also block YouTube or streaming media, like we want to block all streaming, but we also want to allow for the some other user. Okay, like HR or CEO, we want to allow everything for CEO, but we want to block like we have a developer in our office, so we want to block a social media and streaming network for the developer user. So those kind of policies we can create an application level filter firewalls. Okay, because it's a application level. What is application? As I said, it all are the layer 7 application we can allow and block at the application level of firewall. Okay, kind of a proxy firewall. Okay, guys, any doubt for in application level firewall?
Yeah, one doubt here. Manpreet, actually, I just want to know, can we block emails via domain?
What?
I mean, I don't want to access general email. Only I
Email.
want to, yes.
Yeah, even email. Yeah, even email you can block it. See, if you are using an email,
No,
those
actually, my
also.
question is that actually I want to use only official email. In same Gmail, I don't want to use my personal Gmail. Only official Gmail should be open. Like in that way, can we block?
Exactly. See that you want to block in your PC. You want to block. You want to access Outlook. Okay, your official stuff is coming in Outlook.com. This is official, but you want to block gmail.com or yahoo.com. Likewise, you can. Okay. Because outlook.com you can able to access, it is allowed, because gmail.com is working on 443. It's a HTTPS, it's the application level of traffic. Okay, so gmail.com, most of the offices has a blocking of gmail.com because they don't want to share their personal information, right? So there gmail.com, yahoo.com, all are blocked, all are social media blocked, everything. So like that, there is also some kind of stuffs are called, like if you want to block facebook.com. okay, so you can create a policy like facebook.com. okay, so if you block like www.facebook.com and deny, if someone would initiate a traffic of https.facebook.com, it's going to work. Okay, so that's why you have to create a policy like star.facebook.com. it's called regex. Okay, so if anything would come from before star, it could be www. Or could be https, all is blocked. So actually that's the way once we will talking about the application level firewall, the Palo Alto, there we can able to learn about them. Okay, so hope it is clear for the application firewall.
Hello, Manpreet.
Please.
Actually, could you give me any precise difference between application level gateway firewall and web application firewall?
Web application.
Yeah, WAF.
Okay. See, okay, 1 minute. This is application level. Okay. So, web. So, can you explain what is application level? What you understand from the application level firewall? Can you explain first? What you understand?
Actually, application level firewall is a level layer 7 firewall. Actually, it works as a proxy. Anything if we want to block any traffic, URL based traffic or application based traffic, it can do content inspection and signature based analysis, and we can block those things with the help of application ID or URL filtering, like those kind of things.
Exactly.
Yeah, this is application level gateway firewall. And what about web application firewall?
See, web application is just similar to that only. There also we can able to filter, actually more we can do filtering and blocking into the WAF. Okay, not only for the application level. So WAF is just like a similar of the proxy firewall only. Okay, so actually we have a technologies in the in our Palo Alto firewall where we can learn about the application and the WAF also, because our Palo Alto is a next generation firewall, so all are the features there. So we can explain, it is the same kind of features. Okay, so we can explain the working of the application level and WAF into the when we will learn about the lab. Okay. Okay. So this is the next generation firewall. What is next generation firewall actually? Okay, so next generation firewall, guys, understand here. So like as I explained now, stateful firewall. Okay, then I explained you about application firewall. Okay, and if anyone aware of IPS, anyone knows IPS? Okay.
Yep. Intrusion prevention.
Exactly. It's a intrusion prevention system. Okay, so what actually IPS is doing, I want to explain. So like if any traffic would coming from internet, any traffic coming from outside anywhere, okay, so if it is come to the IPS have a signature database. It has a database of signatures. What is called signatures? Signature is the antivirus, like all the attacks, whatever the attacks happen till from the very beginning to till now, all are the attacks or viruses signature it has. Okay, and so those are the signatures actually. So if any packet would come, it will check all the signatures, okay, for the packet. If any packet would match with this signature, it means this packet has some kind of malicious or warm stuff. It will simply discard it. Okay, it will simply block it, whatever the policy we have created, block or would detect. Okay, because it's an intrusion prevention, it will block it. But if the packet there is a no signature would match, it means it's a normal packet, it's a safe packet. It will then forward to the application gateway and then our stateful firewall and then to the user. So now we understand the IPS. So what is next generation firewall? Next generation firewall is a combination of stateful firewall, application level firewall, and IPS. It's combination of all three. Understood? So it has a combination of all three. It is also working as a stateful, also application filtering, also like working as IPS, also have antivirus features. It has a features of everything. So that's why it's called next generation. Okay, it has a features of everything. So once we will learn, we'll go inside into the lab of the Palo Alto Firewall. We will know the features, whatever I will explain the features, you will know more about what the next generation firewall will does. In the Cisco even there is a one UTM, right, or FTD firewall are there. Okay, those are also the next generation firewall. But why Palo Alto is number one? Because I'm just explaining here why Palo Alto is next generation firewall. Because if any packet would come for checking IPS, for doing the web filtering, for processing the any network and any NAT or any policy lookup, it is doing everything in one go. In one go means at a one time. At a one time, like in a Cisco firewall, first packet like it's a one firewall only. It's a one next generation firewall. Okay, so if any packet would come to the next generation firewall, first it will go for the IPS module, like IPS module, and then it will, once it will check, then it will come to the proxy module, then it will come to the your route lookup, policy lookup, everything, then it will pass to it. So it will take some time. But for the Palo Alto, it will checking all the three stuffs at a one time. Okay, at one time. So why it is checking at a one time? It has some kind of features with that I will explain tomorrow, because that's all called the architecture design of a Palo Alto firewall. So that's why all the stuffs we are doing in a one go. That's why it is very much fast. It is a very high throughput and very low latency. That's why it's called the best next generation firewall, Palo Alto. Okay, so for the next generation firewall, that's all. And now I'm moving to transparent firewall. What is transparent firewall? Transparent firewall is where the firewall is working as a L2. It means L2 is what? Working as a switch. Like suppose if this is a L3 switch, okay, L3 switch, and there is a one router, and there is your connection, whatever, internet. So like suppose this interface has some IP defined, okay, 10.0.0.1, and this interface has some IP defined 10.0.0.2. And if suppose in your organization or in your office there is a requirement came that we have to put the firewall in between that. Okay, so if you want to put the firewall in between that, as we know that firewall working on L3, we have to be change the topology, right? And because this interface of firewall will require a one physical IP address. So that's why it is we have to be change all the topology. But for the transparent firewall, we can work as a firewall as a L2. It means like a switch, but it will filter and it will filter the traffic. It will protect the network as like a L3, but it is work as a L2. That's why only one IP required for the management only, and it will work on the MAC addresses or frames. So that's called as a transparent. In the firewall, it's called wire. Okay, wire interface. Okay, wire firewall. So these are actually the types of firewall which I want to explain. Okay, so when these are the vendors of firewalls: SonicWall, WatchGuard, Fortinet, Stones of Checkpoint, Juniper. These are the devices. Actually, these are the company actually making the making the firewalls, and Palo Alto is the number 1 into that. Checkpoint is number 2, Cisco is 3, and these are the 4. Okay, and this is a certificate. Actually, this course is for the PCNSE. Whatever I'm teaching you, it's an expert level of certification. If you want to go for certification for PCNSE, you can. Either if you want to go for the certification for PCNSE, I will recommend to go for PCNSE, because I think it has a $140 and this one has a $160 cost. And this one has a very high, high in demand, and yeah, and it will provide a very good job and everything. That is a very much in demand certification in Palo Alto. Anyone have question?
Oh yes, sir. Sir, those are the features of the Palo Alto, now, like next generation firewall, transparent and stateless, and whatever application layer,
Okay.
gateway, firewall.
Those are the types of firewall.
Packet filter.
Yeah.
Types of
Those are
firewall.
the types of firewall. Yeah, types of firewall. So first we learn packet filter firewall. Okay, as I explained, it is a
Okay.
stateless packet filter firewall, as it's a stateless firewall.
Stateless firewall, yes.
So
sir.
for creating a one connection, we have to be created 2 policy in that firewall. It is an old firewall. And second is stateful firewall. As I explained, in the stateful, it maintains the state table, or it's also called connection table. Okay. So for creating a connection, whenever if traffic coming to the firewall, we can only create a one policy. No need to create for a return packet. Okay. So that's why it is, because it is maintaining a state table. It's called a stateful firewall. Third, we have learned about the application level of firewall. What is application
With
firewall?
the web-based traffic.
Exactly, web-based traffic like Facebook.com, YouTube.com, whatever we are using from the browser, it's called web-based traffic. We can filter, we can allow and block the URL. What is URL? Like Facebook.com is a complete URL, right? So we can allow or block the URL according to that from the web-based application-based firewall. Then fourth, we have learned about the next generation firewall. So next generation firewall is what? Our Palo Alto firewall is a next generation firewalls. Okay, because these are the old. So the next generation firewall is a mix of everything, like a stateful, application, and IPS.
So
Both are
Palo Alto comes under the next generation firewall.
exactly.
No?
Yeah, next
That is
generation
the type
firewall.
of the firewall.
Exactly. So actually tomorrow we will learn about the
what makes Palo Alto the most popular firewall?
Actually, could you
by the
please
company?
explain the transparent firewall?
yeah.
Sorry.
Yeah. I understood your question.
Give me a overview. Just give me
Exactly.
An overview.
I'm going to give you. So there is a one guy asked what makes Palo Alto is a best firewall. As I explained in the I've already explained that. See, what is next generation first? Firewall, like it's a stateful. Okay, just stateful firewall, and then application firewall. Okay, and then IPS. So next generation firewall, like even antivirus or anti-threat policies. Okay, anti-threat policies. So my firewall, next generation firewall, has a combination of everything, all features. Okay. So so what is making Palo Alto firewall is based actually? See that I have already explained, but I'm going to explain again. So if any packet is coming, like suppose this is the features of like if it's a application level of checking, it's a IPS based checking, it's a network lookup checking, it's a policy lookup checking. Yeah. So it's all doing in a one go. All if any packet is coming, it's packet, all stuffs are doing in a one go. Okay, but on the other firewall like Cisco UTM and some other, what is happening? First packet would come, it will check for the, like I'm giving one example, like it will check for the anti threat stuff, or it will check for the malicious, then it will check for the IPS scanning, then it will go for the web-based traffic, then it will move to the, once it check, then it move to the policy lookup, then it will move to the network routing lookup, Once it's all done, then it will process the packet for the next. I know it is not taking much long time, but it's taking some time, like it's moving from the one module to other. But there actually, if any packet would come to the Palo Alto, it is all the stuff is doing in a one go, simple one go. That's it. So that is it. That's why it is very fast. It's very fast. So that's why it is very fast. There is a very low latency and very high throughput. All are preferring Palo Alto. That's why Palo Alto is different from the other vendors. Hope you got my answer.
Yes, sir, I got it. Thank you.
Okay, so you asked about the transparent firewall. Let me explain transparent firewall again.
Just give me overview.
Exactly. Yeah. I want everyone, the concept should be clear actually. Okay, let me clear it. So what is transparent firewall? As I said that, suppose this is your LAN network, okay? In your LAN network, could be there is a one L3 router, okay? And there is a one more L3 router, okay? Suppose there is a some topology, and this is internet connection. It is internet, okay? So if in between, if there is a one firewall need to be required to placed in between these two router, so you have to be change the topology, right? Because firewall is a L3 device, okay? So so if it's a L3, so its firewall interface also required a IP addresses. So as I said, this into these two router, there's already a one network is already connected, or there's a IP is already defined, definitely defined, and you want to put one firewall in between that. So if you want to put your firewall, so you have to be change the topology. That is very, very hard to change the topology. In that scenarios, you have to be, you want a firewall in between that, but you don't want to work firewall as a L3. So you will make your firewall as a switch, as a L2 switch. Okay.
L2 switch.
It's kind of, it's not a switch, but it is work as a L2. It's work on the, what is the L2 I explained, na? Layer 2, where switch is working.
Yes, sir,
yeah. So it will work as a L2, but all the filtering and all the, like as I said, IPS scanning, web filtering and policy lookup, policy blocking, allowing everything, it is doing everything. But no one knows that there is a firewall in between. It is kind of a bump of a wire. Okay, bump in a wire, because no one can understand there is a. So once the transparent firewall topic would come, I can explain very well. Okay, so those topic would come into the lab. Okay, so we can explain those things. That's fine, guys.
Sir,
yeah.
सर ये L2 पे अगर बीच में फायरवॉल लगाते हैं तो उसको आईपी एड्रेस से मैनेज नहीं कर पाएंगे ना?
नहीं, no need, na. So see, if you are putting there's a router, so this is IP address already there, right? There is a 110.0.0. Like there's a one sub network is already there, and we want to put a firewall into that. So it will work as a switch, but there is in this